All right. So we've now learned a little bit about promises. This is going to set us up nicely for later on today when we start making our API calls. But the reason why we needed to learn about promises is because when we make API calls, we're going to be working with asynchronous operations. So by default, right now, JavaScript is synchronous, meaning that if we pull up our code, let's just pull up some code somewhere. So when our code is synchronous, it's going to execute one after another. So it's going to go line one's going to finish. Before line 3 runs, line 1 needs to finish. Once line 1 finishes, well, then line 3 is going to run. And then what line 4 is going to run, and then on and on and on. So it's going to go one, and then another, and then after another. Well, sometimes I may be running some code, and that code is going to take a while. It's I need to wait for a server to give me some sort of a response. Well, in that case, it can kind of like block up my code, where it can kind of take it, where I'm sitting there and kind of waiting. But what if I wanted to kind of continue on, and then wait for that to kind of finish on in the background, and then to go ahead and to kind of run. So whenever we do an asynchronous operation, it's going to get added to something kind of called a queue, which is going to allow my stack to continue moving on. So that if this is going to be an asynchronous operation, it's going to get pushed into the queue, which is now going to allow me to continue moving on and execute anything else I need to. And then once that asynchronous operation has finished, then I can call the code that's going to be necessary for that to actually run. So we're going to have a visualizer, which we'll kind of walk through, and then we can kind of see how that kind of happens in place. But let's take a look at our solution for this one. So we had 2 files. We had the main file, and then we had take a chance. So take a chance is going to be returning a promise. So whenever we're working with an API and we're making network calls, we're going to be working with promises. So there's going to be 3 states with a promise. There's a pending state, there's a resolved, and there's a rejected state. So as we talked about, JavaScript is synchronous. So it's going to do one line, and then it's going to do the next line, and then it's going to do the next line. Well, in order for my line to kind of be done, that's why a promise returns a pending. So I kind of got my result back. I got something. So now this is done. It's pending, but I now have allowed my call stack to free up so that I can go continue to move on. So the immediate thing that's going to happen is going to return pending. So we got some sort of a response so that our code continue moving on. However, we're performing an asynchronous operation. It's going to be happening in the background. So we use the set timeout to simulate a network call, because when you make a network call, it's going to take a certain amount of time, right? So we just use the set timeout to add a little bit of a delay. So we're just forcing us to wait for 2 seconds to kind of simulate what it would be like to kind of wait for a network call. And then based after those 2 seconds, we're just generating a random number, and then we're comparing it to that 0.5. So it's just completely random whether or not this is resolving or rejecting. We're just kind of using it to show it as an example. So if this resolves, so if this is true, then the promise is going to return a resolve. However, if this is false, then the promise is going to reject, and it is not going to be fulfilled. So we have those 3 states. We have the pending state, we have the resolved state, and then we have the rejected state. So over here in main, what I did is on line 3, I called my take a chance function. So now I called take a chance, which is over here. We'll put these side by side. Put these cameras down here. So I'm now calling take a chance right here on line 3, and I'm passing in my name. Well, since my promise has a set timeout, what is this initially going to return? What state?
We're still pending.
We're in the pending state. So now this is going to return pending. So now if I were to log promise, promise would have a pending state. So now my code continue moving on. Well, once my promise resolves, I have 2 other states. I have a resolve, or I have that rejection. So if my promise resolves, then what's going to happen is it's going to call my then method. So as soon as my promise were to be resolved, then it's going to execute whatever code I have in my .then. Whereas if my promise rejects, it's then going to execute any code that I have in my .catch. So this is how I'm essentially being able to listen for when my promise eventually resolves or rejects. Because I'm chaining these methods on the variable that is storing the promise. So take a chance is returning a promise, right? It's in that pending state. So now promise is my promise object, and it will have these two methods that once resolve gets returned, it'll automatically call my then catch handler and it will execute that. Whereas then if it rejected, it'll call my catch. So now if we go and if we run this, so here, clear this. I'm going to do tsx main.ts. So now it's going to go and call Dave. It's going to go call the take a chance. So it's waiting the 2 seconds because the set timeout. Now you can see my promise rejected, which called my catch handler, which then logged my error message. So we can see it's just bad luck name. It's just bad luck Dave. So what happened is when I created a new error, that's creating this error object right here that I got passed into my catch handler. And the actual message is accessible via that message property. So my rejection got thrown from my promise, which caused my catch handler to run. Let's see if we can get the then handler to actually run. All right, we got it that time too. So now the next time I ran it, I called take a chance. I then tried to generate that random number and compare it to 0.5. In this case, it was successful. So now my promise resolved, which means that it executed all the code in my .then like so, which is the hooray, you're so lucky Dave. Just to show you, we could add some more console logs. So let's do a console.log promise was resolved. And then we could also do a.
It's a callback function.
Yep. Promise was rejected. Okay. So if this promise resolves, it's going to call my .then method. Whereas then if this promise rejects, it's going to call my .catch method. So now if I were to run this, but now you can see I got my console log promise was resolved, which was right here. And you can see it also said the hooray, you're so lucky Dave, which is that message that got returned right here. So it's only executing one of them. It's executing either my then or it's executing my catch. And that is my way of essentially managing how to handle each of the states of our promise. You can see, let's say if I tried to console log promise right here. So I created promise on line 3, and now I'm trying to log it on line 5. We'll see what happens when I run it. You can see in my terminal, promise pending. So on line 5, I tried to console log my promise object before it either resolved or rejected. It was in its promise state. So the only way for me to know once the promise finishes is via these two methods as of right now. We'll learn about other ways. But as of right now, we have that .then and we have that .catch method. Yeah.
So the pending, is it from the terminal or did you put this?
That's my console log right here on line 5.
Did you put the message pending?
That's what it got returned because it's in the middle of the pending state of the promise.
So promise, it's built in the word.
It's an object that take a chance is returning a promise. Return promise.
The new
So-
promise object with two,
Which is the pending state.
with two callback function. One is
Only one
Resolve.
callback function.
because it's calling resolve and it's calling reject. So both are the callback function.
That's inside of promise. That's not what gets returned here. Only the promise object is getting returned.
Because then is calling resolve and catch is calling reject.
Yeah, inside of here,
Yeah,
inside of the promise.
so
The
it's like,
promise object is what's getting returned.
uh-huh.
The callback function is inside of the promise.
But well, what I'm saying in line 2, the resolve and reject are two callback functions.
This is one callback function. This is one function.
So
With
there
two
is
parameters.
the one parameter is both are names. The dollar sign name is could be a resolve or reject, right?
No, that is the parameter
Oh,
from
yeah.
my take a
Oh,
chance function.
The name. And resolve and reject, where are they passed?
I'm creating them. Those are parameters, just like how I created name.
Yeah. So the resolve, so the resolve, we have a resolve and we have you are so lucky name and reject. You see, like the reject is.
Yep.
Is it like a call? It's like a function, like.
Yep.
It acts as a function.
Yeah, so when I have promises, like I said, I have my 3 states. I have my pending, my resolve, and my reject. So whenever we create a promise, I either need to resolve or I need to reject that promise, which is.
Yeah, is it like line 5 and 6? Line 5 reserve is.
Yep.
Resolve, so is correspond with resolve
Yep.
parameter.
Yep.
Reject.
Yep.
Uh-huh.
Yep. You never really create promises like
Yeah.
this. You're never really going to be creating promises. You're going to be handling promises. So what you're going to be doing is more so on the left, because we're going to be calling APIs and we need to handle those promises. It's very rare that you would ever actually create a promise and be doing the resolving and the rejecting yourself. You're going to be just handling the resolve and the reject.
So just creating a promise at line 7, like an object coding.
Return new promise. This is creating a promise object.
So it's an object that has 2 methods, then catch. It's like
Correct.
similar to promise.then, promise.catch.
Exactly. Exactly.
Oh.
Rukaya?
Why did you say that we won't be creating promises? I mean, if we won't, then who would be?
Sorry, can you repeat that last little part?
So I'm saying that if we don't create promises, then who creates them?
The people that are creating the APIs.
Okay.
Yeah, so it's like as a front-end developer, when I make a network call, I'm going to be receiving a promise back, but I'm never the one doing the new promise. This is what the server is sending me back. And
Okay.
even when you're in the backend and you're creating your own APIs, you're still not creating the promise yourself. You're just going to the database and then you're returning the response.
Okay. And on the left, where we have promise.then and .catch, so that is like a fixed syntax. We can't have like catch before then, can we?
I mean, let's try to reorder it. I think the then has to come first. Actually, it's. In this case, let's test it. But I wonder if my .catch, so let's do tsx main.ts. It's just bad luck. Promise was resolved, and then I got undefined. So let's see. So promise was rejected, which was right here. And then I got the message, which was it's just bad luck. But where does my undefined come from? Where did I get the undefined? Oh, my then I think still technically ran. No, because I didn't get, oh yeah, my then also ran. See, technically it also called promise was resolved. And then I got undefined. So even though well, maybe it's because, let me make sure it has. So let's do it like that. And let's do catch. Let me just make sure it's perfectly.
Oh, well, what we are doing now?
We're just seeing if the order of the then and catch matter.
The order.
So now in this case, this resolved. Promise was resolved. Hooray, you're so lucky. Let's see if we can get an error again. So it looks like it works technically. If we don't get an error, then it would only execute the then. However, when we do when the promise does reject, it's calling our catch, but it is also calling the dot then after. Because when we do dot then, we're just chaining. We're saying do this and then do this. But if we have the then first, this then would only get called if this were to resolve, and then there wouldn't be anything after the dot catch. So the next exercise, we're actually going to be learning about a whole different way of doing dot then and dot catch. So this is actually an old way of handling promises, but we have to teach you this first before we teach it the new way. So you probably wouldn't even write your code like this to begin with. But if you were, then you usually still would do your dot then and then do the dot catch after.
Okay, and I also had one more question. So the message parameter that we're passing in then, and then we're logging on line 10. So I mean, so that message is just a name. I mean, just a variable name. We can have anything instead of message, can we? Or
Yeah, I can call this Ru Gaia, and then I could still just console log that. Hooray, you're so lucky. So it's
Okay.
just like any other parameters, just whatever you want to call it.
and what about error.message, like the message?
Same thing. Yeah, same thing, just a parameter. You can call it whatever you want, but this is where the way you name things is very important. Because if you don't call this as error, since I know what a catch is, I know it's catching an error, but it just helps readability when I go through and I read it. Oh, I'm catching an error and I'm logging the message of the error. So you can call it whatever you want, but this is a great example of why I would want to call it error.
Okay. So the message property is there for like whatever object name that we give it.
It's there, it exists on an error object. So how we're doing new error and how I call new error and I pass in this string. So error is a whole object and the message property is specifically that string that I passed when I created the instantiated the new error.
Okay, and why don't we use the throw keyword here?
Because when you use throw, it's going to stop the execution of any other code because I'm now the one throwing the exception. In this case, I'm not the one that's throwing it. My promise is the one that's throwing it. So I'm just creating the error for my promise to throw.
Okay, got it. Thank you.
So I think a good way to think about the asynchronous is we could see the event loop in action. So the way the event loop is we have a call stack, and then we have these queues. So what happens is in my code, when I start calling things, they're going to get added to my call stack. And then it's going to start executing things in my call stack. So in this case, the first thing that I do is I call my first function on line 21. So what's going to happen is line 21 is going to run. It's going to call, and it's going to add calls first to my call stack. And then it's going to see what do I need to do inside of first. Well, what do I do inside of first? I call second. So second's going to get added to the call stack. So let's go ahead and let's see this. So this is the synchronous nature of how JavaScript works. So let's go ahead and then let me move these cameras, get them out of the way a little bit. So the first thing that's going to happen is I'm going to call first. So now you can see first got added to my call stack. Okay. Well, what's happening inside of first? I'm going to call second. So now you can see second gets added to the call stack. You can see first is still a part of the call stack because we have not finished calling first yet, right?
Yeah.
Because in first, it's calling second. So in order for first to be done, everything in second needs to have been done. So you can see, well, what happens in second? It's going to call third. So now third is going to get added to the call stack. So this is going to keep on going.
Oh.
Yep. And now we've reached the last one. So inside of my 9th function, I called 10th. So now 10th got added to the call stack. So right now, we would be executing whatever is inside of my 10th function, which in this case is nothing. Now I've finished everything in my 10th function. So it's going to get popped off the call stack because I've now finished everything inside of that function. I'm now going to check to see, is there anything left inside of this 9th function to run? In this case, no. So it gets popped off the call stack. Then it's going to do the same thing with 8th. Is there anything left in that 8th function? Nope. So now it's going to get popped off the call stack. Okay, 7th. Is there anything I'm supposed to finish running in the 7th function? Nope. So it's going to get popped off, and it's going to keep that flow on and on and on, just so that we can see it. So let's add some console logs, for instance. So console log 10 function. And then we can also add a console log. Let's do 9 function after 10 function. Okay, so let's just paste this inside of here just so that we can easily see the code that we're working on. Okay, so we still have those 10 functions, but now inside of the 10th function, I added a console log. And inside of my 9th function, I also added a console log, but I added the console log after I called 10th. So let's go ahead and let's do this. We're gonna run. What's the first thing that's gonna happen?
It's gonna run first.
Okay, so first is gonna get added in my call stack. Inside of first, it's gonna call second, which is gonna keep calling all the other functions. Okay, I'm now inside of my 8th function, which means it's going to call my 9th function. So now I'm inside of my 9th function. What's the first thing inside of my 9th function?
It's the 10th function.
The 10th function. So now it's gonna call the 10th function. So now you can see 10th got out of the call stack. Now it's gonna execute everything inside of my 10th function, which in this case is a console log. So now we can see I got a console log. 10th function. Is there anything left in the 10th function? Nope. So we're gonna pop it off the call stack because we've now finished everything. Well, now I'm still in my 9th function. So I finished 10th. Well, what else comes inside of my 9th function after 10?
Let's come the console log.
The console log. So now I'm gonna see my next console log. 9 function after 10 function. There's nothing else left for me to do inside of the 9th function. So now I pop it off the call stack, and then we do the same thing. We keep on going. So this is the synchronous nature of JavaScript. One line is going to run. Once that line's done, it'll run the next. So in this case, we call the function. Inside of that function, we call another function, and it's going to keep on going. Any questions about this before we get into how asynchronous changes this?
So first synchronous.
Make sense so far? Okay. Now let's say I did this. Let's say I added a console log. Hello. Now I did a set timeout. Yeah, I think the O is lowercase, is it? Yeah. So set timeout. That's gonna run in 1 second. And this is going to console log inside of set timeout. And then console log hello after set timeout. We'll do hello before set timeout. We have the console log inside, and then we have the one after. Okay. So, oh, I think I have. There we go. So any guesses right now? What do we think is going to happen? So what's the first thing that's going to happen?
Line 1.
Line 1, right? So the first thing I should see is a console log, right? What's the next thing that's going to happen?
Line 3.
Line 3. So you think I'm going to see the console log for the inside of set timeout?
Yeah, supposed to look at it, right?
Line 7.
Sorry, Rikai?
Line 7 will execute first.
Line 7 is going to execute first. I have a set timeout, right? So when does this function run?
After 1 second.
After 1 second. So watch what's going to happen. So the first thing that happened was my console log on line 1, right? Well, the next thing that's going to happen is you can see that something got added to a queue. It says anonymous. So what just happened is I had this anonymous function, right? The set timeout. This is an asynchronous operation because it's gonna be executing.
After 1 second.
Exactly. So I don't want to call it immediately. It gets added to the queue. So now my call stack is empty. So what's gonna happen? Well, it's gonna move on. So now you can see it went and then it logged the console log on line 7. So now I get the hello after set time. Well, now what's gonna happen? I have no more code to run, right? My call stack is empty. There's nothing else. So this is where the event loop comes into play. My call stack is completely empty. There's no more code for me to execute. So what's gonna happen? I'm gonna check the queue to see if there's anything in the queue for me to do. And if so, it's gonna get moved to the call stack and then it's gonna get executed. So now as soon as I hit this next step, you can see my anonymous function got moved from the queue to the call stack. And now it's gonna execute in the call stack, which is gonna execute my console log. So this is the power of asynchronous, is that it allows my code to essentially still kind of move on. So set timeout is asynchronous by nature. So just by using set timeout, it's gonna add it into the queue, which will allow my code to be unblocked, to go ahead and continue executing anything else that it needed to, so that once it finished off, it can then go grab the thing from the queue. This is exactly why I said this time that you pass as the argument is a suggestion. Because what if I had so many things in my call stack that it took longer than 1 second? Then it can't go grab from the queue until it finishes the call stack. So ideally, it's fast enough where it usually matches up, but it's not a guarantee. Rukaya?
So if we had given, if it created a variable for a set timeout function, it wouldn't be anonymous, it'd be the variable name, right?
So you're saying like if I name this function?
Yeah.
Edit this.
The same thing.
Now you can see it says yo, because that's my callback function that got added to the task queue. And moved it. Yeah, so just because the function didn't have a name, that's why it said anonymous. But as long as the function did have a name, then yeah.
Okay, and what are microtasks?
So there's technically micro tasks are specifically, I hate that they do this. I mean, they're right technically, but I think it kind of makes things more complicated for you guys. Micro task is specifically for promises. So all other asynchronous operations get added to the task queue. Promises specifically get added to the micro task queue. And the only difference is the micro task queue is a higher priority. So what's going to happen is once the call stack is done, the first thing that's going to check is the micro task queue. If there's nothing in the micro task queue, then it's going to check the normal task queue, and then it would go from there. So that's pretty much the only difference, is the micro task queue is a higher priority, and it's only going to be used for promises. So it's, while technically it's true that there's two different queues, I think you can still just kind of think about it as there is a queue where asynchronous operations are, and once the call stack is empty, it's going to go look for those queues. But if we're being very, very specific and technically, there are technical two different queues. The micro task has a higher priority, and it's only reserved for promises.
I'm sorry, why doesn't the event loop say that evaluate script, run a task, run all micro tasks? So like, why is that the order then? I mean, if micro tasks are of higher priority.
I think when it's saying run a task, I don't think it's necessarily saying run. I mean, we could let's check it. So they have a task versus micro task. So if we do a run, something gets added to the task queue. You can see the micro task gets moved first, and then it'll grab the task queue and it'll move that. So I think it's just a wording thing on their part. When they said run a task, I don't think that they actually mean run the task queue. I think they're just saying like one of those like little blocks in the call stack, like literally run that task.
Or maybe they just meant that, add it to the task queue. So that could also be.
Well, I got added to the task queue, right?
Yeah, so that's when it happened. And also that's evaluate script.
Yes. So right now we're evaluating our script because we're synchronously executing through the script. So
Okay.
we've now executed our script, evaluated it. So now we have our things in our queues. So now our call stack is empty. So it's going to check the microtask queue first because it has the highest priority. It's going to check to see if there's anything from here. It'll move it to the call stack, and it's going to repeat this until the microtask queue is empty. So it's going to execute the call stack. Technically, what the call stack is doing now is it's checking the microtask queue again. But since the microtask queue is empty, then the next thing it's going to do is it's going to run the next task. So when it says run a task, that's saying that it's selecting from that task queue in the microtask.
Okay, got it. So we've only learned like two types of asynchronous functions. One is the set timeout and the other one is a promise, right? Like we haven't done anything else that's asynchronous.
Yes, I mean, any web API, so set timeout, set interval, those are all asynchronous. And then with promises, you're going to be using fetch to make your network calls. That'll be the other way of using promises, which is why I was saying like you never really create promises, you just handle promises. And the only way, like we only really handle promises when it comes to network calls.
Okay, thank you.
Okay, so the previous example, for the micro task, so the first thing happened one line, we execute line one. Function, then inside we call the function A.
We're passing a function.
We passing a function, yeah.
To set timeout. So the first thing that's going to happen is I'm calling set timeout, which is an asynchronous operation. So what's going to happen is this callback function is going to get put in my queue.
But there's a zero wait. There's a wait.
But it's still asynchronous. Doesn't matter what the time is. I used an asynchronous function, set timeout.
So it's called function A.
I didn't call it. I passed
Pass it.
function A to set timeout. Okay. And now the next thing I did is I resolved the promise. Well, I passed B to my promise resolve. My promise is resolved. So it pulled from the micro task first. It executes my function B, which currently doesn't have anything. And now it's going to pull A and then it's going to execute A.
Put it in the task.
Yeah.
The stacks.
Yeah. So only difference is micro task, higher priority, and only specifically reserved for promises. So promises always have the highest preference priority over any other asynchronous operation. So let's take a look at this example. So we have three set timeouts. We have the A, B, C, we have the function D, and then we call D on line 9. So when I run it, what's the first thing that's going to happen? Thoughts?
Function D will run.
Function D will run?
Or line 5.
Seven.
But I don't know.
Don't know. Okay, that's a valid answer.
So it's gonna see line 1 first, set timeout.
Okay.
It's gonna put it in the task queue. Go line 3 is gonna put it in task queue. Line 5 put it in task queue. Then we'll execute line 7, put it in the task.
Well, line 7 isn't a
stack.
7 isn't an asynchronous
Function. Why it's asynchronous?
It's not asynchronous.
That's
Function is
not-
asynchronous. Why would it get added to the queue?
It's not added to the queue, it's gonna be added to the call stack.
It'll be added to the call stack.
And line 9 is gonna be added to the call
This
stack.
isn't well. So, Rukai, what were you saying?
Yeah. So like exactly what Noah is saying. So yeah, we'll run function D first, and then we go to the task queue and then see B and A.
Okay. So we'll hit step. So the first thing we did is we added A to the queue. We'll add B to the queue. We'll add C to the queue. Now the next thing that's gonna happen, I call D. So now D got added to my call stack. It's executing all the code inside of D, which is nothing. So it's finished. So it pops it off. Now what's gonna happen?
Gonna go back to the first one, set timeout.
I think A will run because that's like the oldest task that got added.
Okay, so you think A is gonna run because it was the first one that got added. You also said A, Noah?
Is it FIFO or LIFO? It's a first in, first out, or is it last in, first out? For the queue?
Last in, first out.
For the queue.
Oh, for the queue, you're saying.
So the oldest one will be last in, first out. Or the
mm,
first in, first out. So it's gonna start from A or will start from the O?
It kind of depends. So watch. So right now, so Ricardo, you said A. Noah, you said A, right?
I say probably C.
You said C. So Ricardo thinks A. Noah C. Trey?
I think it's in the order they were received, so it'd be A.
Be A. Okay. Or C.
Yes, the oldest one. LIFO.
Wasn't the oldest one. C got added in
The
third.
newest one, sorry, the newest one, last in, first out.
So let's test it. What did the number C have?
Yeah, I mean, C got added because of the time that we've set, like the 0 milliseconds. So I think it's because of the time. I mean, if the time was the same for all of them, then A would be out first. I mean,
Oh, yeah.
A would get executed first, yeah.
What if I did 0? So what if I did 0 for all of them? Okay, now I have 0. So in the last one, A was the last one that got executed because it was 1,000 and then 500 and then 0. So the last example that we did, C was the first one to get executed. So do we think C is going to be the first one to get executed now, or do we think now it's going to be A?
It's the same second, wow, so it's gonna be the same thing. C is
You
gonna
think
be,
it'll be C?
wow, why is this, I don't know, it's kind of weird. So the previous example, we put like, did you put them in the second order, we put like.
So the task queue is a first in, first out. So whatever goes in first is going to be the first one out. But when we use set timeout, we have a number, right? This number is indicating when that is going to be executed, you know? So since we're using the set timeout, this is essentially dictating where in the queue it would have gotten executed or pulled first. But when we're working at the same level, then it goes from the first in, first out model.
Same level, same time.
Trying to just answer your question.
Yeah, I was just gonna ask. You kind of answered it right there, but would it actually go back through A and B before it got to C with the 0 time? I mean, would it go back to A and said, "Oh, okay, you're still on timeout," and go to B, "Oh, you're still on timeout," and then go to C and say, "Okay, you're done, so we're gonna execute you now"?
Okay, so what you're saying is that in theory, if if this was at 1,000, for instance, and this was at 500 or whatever, C is going to be the one that's executed first. But are you asking if technically we're checking on A first before we just grab C?
Correct. Since it is in the order it was received, is it going to look at A before it actually gets to C, or does it just automatically go to C?
It's just pragmatically going to the task queue and it's seeing what task queue is ready to essentially be called or finished. So in this case, since this is the only one that is ready to be called, it's gonna grab that one. And then in that case, it would have gone to the next one. In theory, you know, if like, let's say this process would have like lasted 2 seconds, where in theory, you know, all of them were like subject to be ready to still be grabbed, it would still know to grab C first and then grab B and then grab A. Essentially, what's happening is that like when this finishes, like JavaScript needs to know that it's like been called or like executed. So that's why like with the promises, right, with the micro task, like we have those three states, like the pending, and then the pending comes up fulfilled or the rejected, is that, well, my JavaScript engine needs to know when to kind of go back to that queue and to kind of pull it from the call stack. So specifically the promises, that's why we call that resolve, or we call the reject. So that we're calling another function that we can go add back into the call stack. Yeah.
So if we have so the first one's gonna be the oldest one added to the queue.
To the queue?
To the task queue.
Yeah.
If
So,
we have like 3 promises
uh-huh.
and we are expecting an API call, we are calling 3 times. So the
Mhm.
first API call, for example, get, and we put it at the task queue. And we have another API call, it's like a update or put.
So API calls would never go to the task queue. It would only ever go to the micro task queue. Because it's a promise.
It's inside the promise, right?
Promises are always micro tasks.
Oh,
Any other asynchronous operation is just a normal task. But a promise is always going to be a micro task. And again, the promises is they have those states with the pending and the fulfilled. So if a promise is still pending, it would never get moved to the call stack because it's still pending. We would only move it to the call stack once it's been resolved or rejected, because that is calling that resolve or the reject handler.
so if you have 3 promises,
Uh-huh.
if you have 3 promises, they're gonna be executed in the same way as we did here, like when you put 0, it's gonna be, is it the first one?
Whatever one would resolve first.
Whatever.
Like that would depend, you know? It's just, if I'm making a network call to India
Oh, okay.
versus making a network call to California, it's gonna be 2 different times,
Oh,
right?
yeah.
So then based off of whichever one would have resolved first.
Oh, okay.
Yeah.
If happened the same time.
But it's the same thing kind of right here, right? Like, I'm telling it when to resolve. Resolve in 1 second, resolve in 500 milliseconds, resolve in 0 seconds. So when they all have the same resolve time,
Yeah, like
then it's
it.
first in, first out. But if they didn't have the same resolve time, then it's gonna go based off of
Uh-huh.
whichever one resolved
Okay.
first.
First and first, the
Yeah.
oldest one
Yep.
is the first one getting out.
Exactly.
Uh-huh. Yeah, but the set time is a last in, first out. Similar to it.
So only last in, first out, if the thing that was last in was the first one to be executed or like fully finished.
When you put the time. Like
Exactly.
1,000
Yeah,
times, this is
exactly,
how-
exactly.
Yeah.
Yes.
Okay.
Yeah. I know we'll still go check out the quiz questions here in a second. But actually let's step through this one. Let's see. Gotcha. Okay.
So in the documentation, there was something called finally handler.
Yes.
What is that?
So for instance, let me delete all this. So right now we have code that's gonna run when my promise gets resolved, and we have code that's gonna run when my promise gets rejected. Well, what if there's code that I want to run in both cases? I don't care if it's resolved or I don't care if it gets rejected, but that's where finally could come into play. So now I could have another function for finally, where, you know, console log, this happens, or whatever. So now we go back and we run our code. Regardless of if my promise resolves or rejects, it's always going to call that finally. So you can see right now my promise was resolved. Let's try to get my promise to reject. Promise was rejected, but you can see I still got my console log in the finally. So the finally method is just a nice, if you still wanted to do code, regardless of if something was successful or if something failed, then that gives you a method to kind of still add any code there.
So final is gonna give you like the last, like the message of execution, like okay, finally happened, the promise happened.
My resolve has happened, my rejection has happened. Is there anything else you last want to do? You know.
Yeah, kind of the line 8 and 12 like makes me confused. Like if you put a promise dot then or the promise that catch, or promise that final would be like more logical for me.
Yeah, we're chaining methods. So my dot catch is being chained on my dot then. And my dot finally is being chained on my dot catch.
Wow.
So you can see that then, this blue parenthesis, and there's a blue parenthesis. I cannot put a semicolon here. As soon as I put a semicolon here, you can see I'm gonna get all these errors. So I'm chaining the methods. So the dot then is being chained on my promise. The dot catch is being chained on the dot then.
So it's gonna be promise dot then dot catch.
Dot finally. Yeah.
Wow.
Which I find this a little bit harder to read, which is why in the next exercise, we're
Yeah,
gonna be
this-
learning about a newer way of kind of writing this that makes our code, because as we just talked about, right? When we read code, we read it sequentially. You know, I read this line and then I read this line. Well, the problem with this is depending on if this promise gets resolved or rejected, I'm gonna have different callback functions. And so now it's not always gonna be, this is always gonna run before this is gonna run, before this is gonna run. There's a chance that this runs and then we jump here, or that this runs and we completely skipped over this, and then we kind of go from here. So the next exercise, we're gonna be learning about async and await, and that makes it a lot more readable and handy because it allows us to be able to read our code in a sequential way, but then we can still kind of wait for those asynchronous operations to complete before moving on. Let's check out the quiz questions though. So Rukaya, could you tell me what is the event queue model of promises?
So when a promise is created, it gets added to the event queue. And all the other code that's in the call stack is executed. And then we execute the promise. So like the promise then gets added to the call stack and then it gets executed. So based on like the resolve or the reject, it then executes itself.
So when a promise is created, that promise task is going to be synchronously put onto the queue, as we noted in that visualizer. So whenever a promise is created, it's going to get added to that queue. Then we're going to continue doing synchronous execution of any code until the function completes. Once that current function completes, then the event loop is going to run. So then our call stack is going to go check the queue. It's going to pull that promise task from the queue. And then once that task completes, it'll either then call or then handler if that promise was successful. It's going to handle, or it's going to call a catch handler in case it was rejected. And then finally, the promise would call the finally method after all of those.
Could you repeat that again?
All of it?
I was just gonna put it on the slide.
So when a promise is created, here, I could just copy my notes and then I could send
Yeah,
it. So
please.
that way you get a
Please.
written out.
Really awesome. Oh, wow, that's really good.
Send it. A Slack channel.
So when promise created, putting the asynchronous function to the queue.
Yeah, so when the promise is created, we put the promise task synchronously onto the event queue. We are then going to synchronously keep executing all the rest of the code inside of the function. When the current function completes, then the event loop runs. So the event loop is the action of checking the queue and moving those tasks from the queue into the actual call stack. So then the task is going to be taken from the queue, moved to the call stack, going to be executed, which if the promise was resolved, would means we'll call the then handler. If the promise was rejected, we will call the catch handler. And then finally, regardless of both cases, the finally handler would be called. Which, Noah, what are the three states that a promise can be in?
So it starts by pending, then the catch, and then.
So catch and then are the methods. What are the actual states? So pending is a state. What are the other two states?
Is resolve,
Resolve or fulfilled.
both fulfill
Uh-huh.
and reject.
Reject. Yep, exactly. So we have pending So that's gonna be the initial state. That means that our promise is neither resolved nor rejected. Then we have fulfilled. That means the promise has been resolved and we're gonna be calling our .then handlers. And then we also have the rejection, which means the promise is rejected and our catch handlers are gonna be getting called. Trey, how can I handle the fulfillment of a promise?
Use the .then method.
So we would use the .then method and specifically making sure that we chain it on the promise object. So you can see like in our code, how we did promise .then. So you would call the .then method on the promise object. So in this case, if I didn't create the variable, I could still do take a chance, Dave, and then chain my .then on that function call, because this is what's going to be returning that promise object. So we would chain that .then method on the promise object. And then, yeah,
I thought it's gonna be starting that catch, and then if it's,
no, we always start with then.
oh,
And then Rukaya, how can I handle the rejection of a promise?
So with the dot catch method, which takes in a callback function that will be executed if the promise is rejected.
Exactly. So with that catch method, which is going to be receiving a callback function, which we then can do anything inside of that. And our catch method is going to be getting an error object passed into it. So then we could access any information of that error that we want.
so it's gonna be starting from then dot catch, right?
It's going to go promise,
Dot
dot
then,
then,
dot catch,
dot catch,
dot
dot
final.
finally.
Oh,
Any other questions about promises?
what would be the, for the first question, what is the event queue model like in short, how we can like?
There's no short way about it. So you have to explain the event queue model. So what I sent in my snippet, it's gonna be the best bet, Anything else? Stop the share. Stop the records.